Hello everyone. For this session, we will start by calculating probabilities for different distributions using our built-in functions. For normal distribution, we use P norm. In bracket, you need to have three values. For example, Q, which is the X value, the mean value, and standard deviation value in order to find cumulative probability. For example, let's say that we have this such of question. Find the probability of S less than and equal to 834, whereby X is coming from normal distribution with mean equal to 800 and standard deviation equal to 40. So in R, we just do P norm in bracket. Q is the value of X, which is 834. The mean is 800 and the standard value is 40. Okay, note that the answer you get using the R will be is similar to statistical table. So this one just run. Okay, and then we will get 0.8023 if it is in 4 decimal places. Okay, then to find the value of X given a probability, we use quantile function. For example, Q norm in bracket, you need to have the value of P, whereby P is the given probability, the mean value, and standard deviation. For example, look at B. For example, let's say that we want to find the value of X if the probability of X less than and equal to X is equal to 0.45, whereby X coming from normal distribution with mean equal to 40 and standard deviation is 6. Okay, so in R, since we want to find the value of X, then we use Q norm. The given probability is 0.45. The mean value is 40 and the standard deviation value is 6. So the X value is 39.24603. Next, for binomial distribution, we use P binom. In bracket, you need also to have three values. You need to have Q, where Q is a X value, the sample size, and the probability of success to find the probability of a specific number of successes. For example, let's say that this one A, we want to find the probability of X less than and equal to 5, whereby our random X variable coming from binomial with n, which is n is a size equal to 10, and the probability of success is equal to 0.5. So we just do like P binom, Q is equal to 5, the size equal to 10, and the probability of success is 0.5. Then we run it. So we'll get 0.6230469. If you want it to be in 4 decimal places, then you can round off the answer. So round, for example, this one I would like to have answer in 4 decimal places, then just round, 4. Hence 0.623. Why? Because after 0 is 4, so cannot add up here. That's why 0.6230. And for Poisson distributions, we use P-poise. In bracket, you need to have Q, whereby again Q is the X value and the lambda value in order to find the probability coming from the Poisson. For example, to find The probability, this one is mistake, not the x. Okay, we not finding the x, but then the probability. Okay, so find the probability if x is less than and equal to 2, whereby the lambda equal to 5, coming from Poisson distribution. Okay, x equal to 2 and the lambda is equal to 5. And then we just do p poise, and then 2, q is equal to 2, lambda is equal to 5. Okay, so the probability is 0.124652. Thank you.